Here's pre-calc. It's part 3 of your lecture for 5.1.1. We're trying to get through these word problems with exponential functions. So we're on letter C. A scientist is growing bacteria starting with a culture of 5 bacteria. That when I read that 5 bacteria, I knew that was a starting point. Let's keep reading. Bacteria grow by multiplying. After 2 hours, there are 14 bacteria. Well, that's gonna. They said after 2 hours, there's 14 bacteria. That's like an ordered pair right there. How many bacteria will be present after T hours? Okay, so I'm going to leave this as an X, but then in the very end, I'll turn this into a T, and I'll turn that into like B for bacteria. So this is a lot more straightforward. This is just bacterial growth. If you wanted to model it, it would start out at 5. And then we don't know what B is. Actually, I'll hold off on the graph until we find out what B is. But we know that the bacteria is growing. So all we have to do is just plug in the X and the Y and solve for B. And then we can get our equation. So it's pretty easy. So 14 equals 5 times 2. 5 times B squared. Okay, so then I'm just going to solve for B. So I'll divide both sides by 5. So then I can square root both sides. And B is going to equal whatever the square root of 14/5 is. So I'm going to square root 14/5. Oh. So B is 1, it's approximately 1.67. So then I can rewrite my equation as Y equals A was 5, B is 1.67 to the X. But then they asked me to do it in terms of time, so I'm just going to use B for bacteria. And that's all. And then I see that it's growing, so I can just go like that. You could do a table also. I think it wants you to. Okay, I'm going to move on to the next one, though. The next one is letter D. And letter D says, Professor Livingstone loves to perform acts of kindness. He decides to conduct an experiment in which he performs an act of kindness for only 2 students. Only 2 students. He then requests that these students perform an act of kindness for 3 new students every day. Each student who receives an act of kindness is given instructions to pay it forward to 3 additional students every day. Assuming that each student is a recipient only once and everyone who has received an act of kindness continues to fulfill 3 acts of kindness each day, how long will it take for the entire student population of 6,100 students to receive an act of kindness? So what I'm getting is that he started out with these 2 students, and then each of the 2 students had to do 3 acts of kindness, or an act of kindness to 3 students, and then those 3 students, and so on. And you're going to have, you don't want to draw this whole graph, but just to give us a little idea of what's going on. And then it would keep going on and on. So we're trying to get Y equals A times B to the X. We need to get a formula or a equation. So the starting point is going to be 2 because there's 2 students to start with. And I wanted the multiplier to be 3 because it's tripling. But if I use the multiplier of 3, all I'm going to get are these little edges of I'm just going to get the very last iteration each time. And I'm not going to draw it because I know it won't fit, but I could draw 3 more on each branch here. And that's, if I use 3 for a multiplier, that's all I'm going to get is the new ones. So it's kind of like the bank account problems. If I just want the interest, then I'll just use the rate, just straight up. But if I want the interest and I want it to accumulate, like I want it to also add in the principal and, you know, the interest I've already earned, if I want a cumulative total, then I need to add 1 to my rate. So I hope that makes sense, that I'm going to add, even though I see that that the multiplier is 3, because of what I'm wanting to count, I'm not trying to calculate how many new students are going to receive an act of kindness on a certain day. I'm trying to find out how many total students are going to receive an act of kindness. So my multiplier of 3, in order for it to calculate the total for me, like to include not just these guys, but these guys and the original 2, I need to turn my multiplier from 3 into a 4, because you add 1 to the multiplier. So that's why this thing's a 4. Kind of surprising. Maybe not surprising. Okay, and then I need to know how long is it going to take for 6,100 students to receive their acts of kindness. So I'm just going to do some algebra here. Half of 6,000 is 3,000. Half of 100 is 50. So 3,050 is 4 to the x. Now you may or may not remember how to solve an equation when x is up there in the exponent. But I'm going to tell you that you might remember from integrated 3, you need to log both sides of the equation in order to get that x down out of the sky, out of the exponent. So you're going to log both sides of the equation. And then that's going to allow you to use the laws of logarithms, the properties of logarithms, and the x can come out front. Now, what's log 3,050 divided by log 4? I don't know. I got 5.78. So it's going to take approximately 5.78 days for all of the 6,100 students to have received an act of kindness. That is actually the end of problem 5-1. I might make videos for the other 2 problems. But that gives you an overview of the different types of problems you can model with the exponential function.